full wave rectifier. Okay, the circuit diagram of a bridge full wave rectifier is here we will use transformer, but here we will not use a center taper transformer. Normal transformer like of a rectifier. Here also we will use a step down transformer, and here we will use a 4 diodes. Like a bridge. Yeah, whereas here we will take a output. This is a load resistance RL, and here we will take a output. Here we will give a input from our flags, which is a 230 volts AC and 50 Hz. Whereas here we will take a output. Here we will take a output signal. So it is a bridge full wave rectifier, diagram of a bridge full wave rectifier. In this, we will not use a center taper transformer. In this, we will use a normal step down transformer. Now let us consider it is a diode 1, it is a diode 2, and let us consider it is a diode 3 and diode 4. Otherwise, you can consider మీరు ఎలా అయినా ఈ డయోడ్ నేమ్స్ ఇచ్చుకోవచ్చమ్మా, లైక్ ఇట్ ఈస్ a diode 3 and it is a diode 4. ఎలా అయినా కన్సిడర్ చేసుకోవచ్చు. Now here we are applying a AC signal. All of you know that AC signal means it consists of both positive half cycle as well as negative half cycle. It consists of, here we will connect a ground, means here we will connect a ground. Okay, here we will apply both positive half cycles as well as negative half cycles AC signal, which is a 230 volts of AC. When we are giving this AC signal to the step down transformer, the use of a step down transformer is it decreases the strength of the signal, means it decreases the amplitude of the signal. Why? Because it is a step down transformer which step downs the amplitude of the given signal. So here also we will get both positive half cycle as well as negative half cycles. So now let us consider, initially I am getting a input as a positive half cycle. Now let us consider, initially I am giving a input as a positive half cycle. So if I am giving a positive half cycle, here I will get a decreased strength of a positive half cycle. Whenever I am getting a positive half cycle as a input here I will get a positive sign, whereas here I will get a negative sign. So means at this point the polarity becomes a positive, and at this point the polarity becomes a negative. Now it is a case when I am applying a positive half cycle as a input. Now here I am giving a positive half cycle, means here I will get a positive sign, whereas here I will get a negative sign. So here I am getting a negative sign, means at this point it becomes a negative, at this point it becomes a positive. Now which diodes are in on condition? Which diodes are in on condition? అర్థం కాలేదమ్మా, ఒకసారి చెప్పండి.
D1 D2 సార్.
How can you say that D1 is in on condition here
Sir,
at this
D1,
point?
D1.
Only D2, sir.
Here D2 is in on condition. ఇక్కడ నెగిటివ్ కనెక్ట్ చేసామంటే ఈ రెండిట్లో ఏదో అని ఉంటుందమ్మా. Here it is a positive. Now positive is connected to the p-type material of a diode D2. That's why D2 becomes a on condition. The same positive is connected to the negative terminal of a D1. Now D1 is in off condition. Similarly, same here also, a negative is connected here. Now
D4.
negative is connected to the negative n-type terminal of a D4. So D4 is in on condition. Here negative polarity is connected to the p-type material of a D3. So D3 is in off condition. So whenever I am applying a positive off cycle, D2 and D4 diodes are in forward bias, means those are in acting like a on switch. Similarly, here D1 and D3 diodes are in reverse bias. So reverse bias. So our diodes are acting like a off switch. So our diagram becomes now. Our diagram becomes it is a transformer, step down transformer. Now D4 is in on condition, whereas this is in off condition. Again this D2 D4 sorry D2 D4 are in on condition. Similarly D1 and D3 is in off condition. Now here I am connecting my load resistance RL. So here it is a ground. Now it is in on condition means now current flows in this direction. So it is in on condition means current flows in this direction. నెగిటివ్ డైరెక్షన్ మరలా ఇది ఈ నెగిటివ్ కి ఇలాగా సర్కిల్ లా కరెంట్ అనేది ఫ్లో అవుతుంది. నౌ వెనెవర్ D3 D1 D3 are in off condition, D2 D4 are in on condition. On condition means now current flows here I am applying a positive off cycle means current flows through resistance from up to down. In this direction current flows through the resistor. So whenever current flows through the load resistance, it develops a output voltage. So we are getting a output voltage in this condition. Now let us consider it is my input voltage and it is my output voltage. So whenever positive off cycle are applying, I am getting a output. So otherwise I will draw another diagram. Let us consider my input. It is my input waveform, which consists of both positive and negative off cycles. So let us consider it is my output waveform. So whenever I am applying a positive off cycle, D2 and D4 are in forward bias condition, D1 and D3 are in reverse bias condition. Now there is a path established through flow path established to flow a current through the load resistance. So whenever current flows through the load resistance, now the voltage developed across a load resistance. Now I am getting a output voltage. So it is a input voltage and it is a output voltage. Otherwise, let us consider it is a input current or output current or voltage. Either let us consider it is a input voltage or current. It is a output waveform. Now let us consider I am applying a case 2. Let us consider case 2 when I am giving a negative off cycle as a input. So whenever I am giving a negative off cycle as a input, so here I am applying in place of a positive. Now I am applying a negative off cycle as a input. So ikkada kuda manaki em vastadamma, here also I will get a negative off cycle.
Negative.
So negative off cycle means here I am getting a now negative sign, here I am getting now positive sign. పైన నెగిటివ్ వస్తే కింద పాజిటివ్ వస్తుంది, పైన పాజిటివ్ వస్తే కింద నెగిటివ్ వస్తుంది. Now here at this point I will get a negative sign, at this point I will get a positive sign. So green marks for applying a negative off cycles, red marks for applying input as a positive off cycle. So here at this point, here I am getting now negative, here I am getting now positive. Now which diodes are in on condition?
D1, D3.
D1, D3.
Yes, exactly. Now negative is connected to the n-type terminal of a D1. Now D1 is in on condition. Negative is connected to the p-type terminal of D2. D2 is in reverse bias condition. It is in off state. So again here also positive is connected to the D3. Now D3 is in on condition, whereas D4 is in off condition. Okay. Now at this point of time, D1 and D3 are in forward bias condition. Those are acting like a on switches, whereas D2 and D4 are in a reverse bias condition. Those are acting like a off switches. Now let us consider my waveform. Let us consider now our circuit diagram becomes it is a step down transformer. Now this diode is in on condition D1, D2 is in off condition. Similarly, D4 is in off condition, D3 is in on condition. Here I have a load resistor RL. Load resistor RL. Now see here. Now see here. Now negative, whenever negative off cycle is applied, now these two diodes are in on condition. Now current flows to the resistor in this direction. Again it will come like this, current direction. So here also current flows through the load resistance in the same direction how the current flows in the load resistance in case of a positive off cycle. So here also I am getting a positive off cycle as a output only. Here also I am getting a positive polarity as a output. Why? Because see here, whenever I am applying a positive off cycle, the current flows through the load resistance in this direction, up to down direction. Whereas in case of a negative off cycle also, whenever I am applying a negative off cycle also, the current flows through the load resistance in same direction like positive off cycle only. That's why again I am getting here positive off cycle. Okay. Similarly, again when I am applying a positive off cycle, again I will get a when I am applying a negative off cycle, again I will get a waveform like this. Now tell me the output equation, current equation of this waveform. This is the output waveform. Now tell me the current equation of this output waveform. The equation for this waveform is, let us consider maximum value or peak value Im. So the equation for this waveform is Im sin omega t. The equation for input waveform is, see here, for first off cycle it is the time period for sine waveform is 2 pi, 0 pi, 2 pi. See here for first half cycle, our output waveform also same like a input waveform. So for first half cycle, whatever may be the input equation, it is a output equation. It is for 0 to pi. See here for second, for negative half cycle, it is for this waveform, the equation is Im sin omega t. But here I am getting opposite to this waveform. So the equation for at that point, the equation is a minus Im sin omega t. Here the equation is a minus. So at 0 to pi, now the equation for I is equal to Im sin omega to from 0 to pi, whereas from pi to 2 pi, our current equation is a minus Im sin omega t. It is for pi to 2 pi. So it is my output equation. So I is equal to Im sin omega 2 from 0 to pi. Why? Because the equation for input waveform is a Im sin omega t. So from 0 to pi, whatever may be the input waveform, so same waveform appeared in the output also. So the equation for output from 0 to 2 pi, same as the input. But see here, pi to 2 pi, here we have a negative half cycle, but here we have a positive half cycle. So the polarity of the waveform is in reverse. That's why from pi to 2 pi, our output waveform equation has a minus Im sin omega t.